Somewhere above the Atacama Desert, a machine the size of a small car is taking a new photograph of the sky, roughly every 40 seconds, all night, every night, and it has just revealed something that was sitting directly above us the entire time, completely invisible until now. Not a distant galaxy, not an object billions of light years away. Something close, something wrapped around our own galaxy like a fog we never knew was there. At the same time, a separate image from the same telescope has exposed the aftermath of violence in a nearby galaxy, 160,000 light years of wreckage left behind by one galaxy tearing another apart, and buried inside the flood of data now. Pouring out of this observatory every single night are thousands of objects in our own solar system that nobody on Earth had ever tracked before. Tonight, we're looking at what the Vera C Rubin Observatory has actually captured since its real survey began, why some of these images are unsettling, even the astronomers who built the telescope, and why the sky we thought we understood is turning out to be far more crowded and far stranger than anyone expected. To understand why this moment matters, you have to understand what just happened. For years, Rubin Observatory existed only as a promise, a telescope under construction on a mountaintop in Chile called Cerro Pachón, built around the largest digital camera ever constructed for astronomy. In June of 2025, it opened its eyes for the first time in a test run astronomers called First Look, producing a handful of preview images that hinted at its power. But that was only a rehearsal. On July 1st, 2026, Rubin officially began its real mission, a 10-year campaign called the Legacy Survey of Space and Time, designed to scan the entire visible southern sky, over and over every few nights for the next decade, building what scientists are calling the greatest cosmic movie ever made. This is not a handful of snapshots anymore. This is a machine now running at full power, and what it's already sending back is forcing scientists to look at the sky differently. Officials at the National Science Foundation and the Department of Energy, the two agencies jointly funding the observatory, marked the moment as a genuine turning point rather than just another milestone. One senior official at the launch described it as the beginning of filming, the greatest cosmic movie ever made. Another called it the start of a mission that will redefine modern cosmology and astrophysics. That kind of language doesn't get used lightly around a project that has been 2 decades in the making. And within days of switching on, the observatory was already proving the excitement wasn't just ceremonial. At the center of Rubin's power is its camera, a 3,200 megapixel sensor, the largest digital camera ever built for any purpose. To put that number in perspective, it is roughly 200 times more detailed than the camera in your phone. Combined with an 8.4 meter primary mirror and a field of view wide enough to capture an area of sky equal to 45 full moons in a single exposure, Rubin doesn't just take pictures, it captures entire regions of the universe in one frame, then does it again 40 seconds later, and again after that, all night long, every clear night, for years. One of the very first deep images released after the survey officially began was nicknamed Ocean of Stars, a single 1.7 gigapixel photograph aimed at a field of stars in the constellation Lupus. On the surface, it looks like exactly what you'd expect, a dense field of stars scattered across the frame in blues and reds. But scientists studying the image noticed something spread faintly across the entire background, something almost nobody outside professional astronomy had ever seen with this kind of clarity. Faint, glowing, wispy clouds drifting across the image like smoke, caught in still air. Astronomers call it galactic cirrus, clouds of interstellar gas and dust floating in the foreground of our own Milky Way, so faint and so diffuse that no previous survey telescope had the combination of sensitivity and wide field of view needed to capture it clearly across such a large area of sky. Here's the part that should sit with you for a second. That cirrus isn't somewhere far away. It's part of our own galaxy, drifting between us and the stars we're trying to observe, and it has apparently been there, unnoticed at this scale, for as long as human beings have been looking up. We spent centuries mapping the night sky, cataloging stars, tracking planets, and the entire time, a faint haze of gas and dust was hanging in the foreground of nearly every image we ever took, too subtle for our instruments to properly resolve. Rubin didn't create that fog. It simply became the first eye sensitive enough to finally see it clearly, sitting there all along, wrapped around the part of the galaxy we call home. If that discovery reveals something quietly unsettling about what's close to us, the next one reveals something openly violent happening to our neighbors. Back during Rubin's first look, commissioning images, in 2025, astronomers examining the Virgo cluster noticed something extending from the spiral galaxy Messier 61, stretching roughly 163,000 light-years out into space, nearly twice the width of our entire Milky Way. It's called a stellar stream, a long, faint ribbon of stars torn loose from a smaller galaxy that wandered too close to M61 and paid for it. According to the astronomers who identified it, The progenitor object was likely a dwarf galaxy with a halo mass roughly 80 billion times that of our Sun, ripped apart by M61's gravity and smeared out into a glowing trail that had never been detected before Rubin's cameras picked it up. Researchers now believe this ancient collision may have directly shaped M61 itself, its bar structure, its bursts of new star formation, even the behavior of the active black hole sitting at its core. In other words, the galaxy we're looking at was built, in part, by consuming something smaller, and the evidence of that act was invisible until an instrument powerful enough finally caught the scar. Both of these discoveries came from commissioning images, test observations captured before the real 10-year survey had even begun. Now that the legacy survey of space and time is fully underway, the pace and scale of what Rubin is finding has moved into territory that's difficult to fully process. Each night, the observatory is generating roughly 10 terabytes of new data and issuing as many as 7 million alerts, automated notifications flagging anything in the sky that has changed since the last time Rubin looked at that same patch. Something brightened, something moved, something appeared where nothing was before. 7 million times a night in a single observatory, on a single mountain, something in the sky is different than it was a few nights earlier. And most of those 7 million changes have never been individually examined by a human being at all. They're sorted automatically by software systems called alert brokers, built specifically because no team of scientists could possibly review a flood of information this large in real time. Think about the scale of that for a moment. Before Rubin, discovering a single new supernova, a single previously unknown asteroid, a single flare from a distant black hole could take weeks or months of dedicated observing time on a single telescope. Rubin generates that volume of discovery automatically, every single night, as a byproduct of simply doing its normal job. Deputy Operations Director Phil Marshall described the moment the alert stream came fully online as proof the observatory was already functioning as a discovery machine before the official survey had even started, with millions of alerts pouring in during just the final months of testing alone. Multiply that by 10 years, and the scale of what's coming becomes almost impossible to picture in advance. Buried inside that flood is a category of discovery that should matter to every single person reading this, not just astronomers. During Rubin's early optimization surveys, in just a month and a half of test observations before the main survey even started, the telescope discovered more than 11,000 previously unknown asteroids, 11,000 rocks orbiting the Sun that no human being, no observatory, no tracking system on Earth had ever recorded before Rubin found them. 33 of those newly discovered objects are classified as near-Earth objects, asteroids, whose orbits bring them into the general vicinity of our own planet. 380 more are trans-Neptunian objects, distant icy bodies orbiting far beyond Neptune. And among everything Rubin has found so far, one object stands out specifically for how strange it is: the fastest spinning asteroid larger than 500 meters ever discovered, tumbling through the main asteroid belt at a rotational speed that defies what astronomers expected an object of that size to survive without flying apart. Sit with that number for a moment. 11,000 new asteroids in 6 weeks, 33 of them near enough to Earth to matter, discovered not because they suddenly appeared, but because they had been out there the entire time, silently orbiting the Sun, completely unknown to us, until a telescope finally became sensitive enough to notice they existed. This is not a story about new objects being created. It's a story about how much of what's already surrounding our planet has been invisible until now, simply because nothing before Rubin had the combination of speed, sensitivity, and coverage necessary to find it. And this was accomplished in a matter of weeks during test observations before the observatory had even started its official 10-year mission. Planetary defense researchers have spent years warning that the greatest danger from near-Earth objects isn't necessarily the ones we're already tracking. It's the ones we don't know exist yet, the ones that could go undetected until they're uncomfortably close. Rubin was specifically designed to close that gap, scanning the same regions of sky over and over so that anything moving against the background stars gets caught almost immediately, rather than slipping through the cracks between infrequent observations the way it might have a decade ago. Scientists now expect the observatory to eventually catalog the vast majority of large near-Earth asteroids still missing from our records, effectively finishing a job that ground-based astronomy has been chipping away at for decades. That, more than any single image, is what makes this moment feel different from every previous era of astronomy. Rubin isn't showing us a universe that changed overnight. It's showing us a universe that has always looked like this, crowded with drifting dust, scarred by ancient collisions, and surrounded by thousands of nearby objects we simply never had the tools to see. For as long as humans have studied the night sky, we've been looking at a picture that was fundamentally incomplete, filled in only with what our instruments happened to be capable of detecting. Rubin is the first instrument built specifically to stop guessing at what we were missing and just go find it, all of it, every single clear night for the next 10 years. Every one of these discoveries, the ghostly cirrus wrapped around our galaxy, the scar of violence stretched across M61, the swarm of nearby asteroids. Nobody had ever tracked, came out of a survey that has barely begun. Rubin will revisit every point in the southern sky roughly 800 times over the coming decade, and each pass will strip away another layer of the picture we thought we already had. If the very first images are already forcing astronomers to rewrite what they thought they knew about our own galactic neighborhood and our own solar system, it's worth asking, honestly, what else has been sitting out there in plain sight, simply waiting for someone to finally build a telescope capable of seeing it? Somewhere in the millions of alerts still to come over the next 10 years, there is very likely another discovery just as unsettling as these, sitting quietly in the data, waiting for its turn to be noticed. If you want to be here for every new alert, every newly discovered object, and every image Rubin sends back over the next 10 years, subscribe and turn on notifications, because this observatory is just getting started. And if the first images are already this unsettling, nobody knows yet what the next 10 years of this cosmic movie are going to show us.